So any doubt regarding the theoretical portion of CDT? कुछ नहीं, बहुत easy है. That what are the key points regarding the continental drift theory? The drifting of the continents occurred. क्यों? Forces दो type के थे. Northward, equatorward force due to the gravitational pull. Westward force due to the tidal force. Then after that, the drifting of the continents occurred कि पहले टेथिस सी फॉर्म हुआ, and after that the गोंडवाना लैंड एंड अंगारा लैंड फर्दर ब्रोक, westward drifting Atlantic Ocean बन गया. Gondwana land further broke and gave right to Atlantic Indian Ocean. Due to Gondwana land के parts some drifted to the west, some drifted to the north, and later on we have the present day arrangement of the continents. Then there were some of the criticisms, we have written the criticisms. उसमें से दो criticisms are common in two positives. That is, someone asked me jigsaw fit, how it can be a criticism, how it can be a positive. उसके बारे में will write it today. That is the jigsaw fit of the continents. Though it is a positive aspect, there is one or two geographers, that is the Taylor who initially gave the idea of the continental drift, and then Wegener gave the theory. Taylor questioned Wegener that why do the coast do not exactly fit into each other. See, this is a coast, this is not a block, it will exactly fit into each other. So एक छोटा criticism है. दूसरा criticism is regarding the glossopetris flora. Glossopetris flora is not found just in this part of the world, that is in North America, in the South America, Brazil. South America मतलब Brazil, Africa, India, peninsular India, Antarctica and Australia. It is also found in Kashmir. And Kashmir was formed much later, tertiary period में. It is also found in Afghanistan. Afghanistan is the part of Laurasia land. So there is a criticism कि ऐसा नहीं glossopetris कहीं पे भी हो सकता है, but again ये बहुत minute criticism है. Fine, regarding the continental drift theory. But what are the major evidences we have written? Jigsaw fit. Fine. Second we have written is fossils. Third we have written is rocks, geological evidence. The fourth we have written is the behavior of the animals, and the fifth evidence is one of the most important and the toughest evidence, that is this comes as a separate short note. Write on the paleomagnetic evidences of the continental drift. अब थोड़ा दिमाग लगाना, थोड़ा इमेजिनेशन लगाना, कल हम फिर से इसको वीडियो में देखेंगे. बट फर्स्ट ट्राई टू अंडरस्टैंड magnetism. Does it occur in the rock? Yes, because the earth is magnetic. What are the metallic minerals that are present in the rock? Earth is magnetic. Earth has north pole and the south pole in the terms of magnet, right? So earth behaves like a magnet with the magnetic north and with the magnetic south. Now question is, why does the earth behave like a magnet? Because it has liquid outer core which keeps on rotating. The earth rotates and there is a liquid outer core. In that liquid is not water, in that liquid is minerals, that is molten rock, not asthenosphere. याद रखना, outer core liquid, I am not saying semi molten. Fine. अब it rotates with such a great speed कि there is a charging of the liquid, static electricity form होता है, and because of this there is a separation of some positive charges, negative charges, and over the period of time this positive and negative charges generate an electricity. So because of the electricity, and rotation, earth behaves like a magnet. You have studied this. Iron rod, if you wind a copper wire around an iron rod, and if through this copper wire electric current is passed, so that iron rod behaves like a magnet. We will call this as an electromagnet. So earth is an electromagnet. Getting it? What is earth? Earth is not a magnet. Earth is a electromagnet. मतलब the day rotation of the earth stops, earth का magnetic property will go. Electromagnet का ये भी मतलब है, that is, it also means that if the liquid changes the direction of rotation, rotation is occurring, revolution is occurring, liquid, if it changes the direction of the rotation, there will be shift in the magnetic field. Why? Because electromagnet में always the magnetic field is to the left hand side of the direction of the flow of electric current. Fine? Left hand rule. Fleming's. If this is the direction of the flow of electric current, this is the magnetic field. If this is the direction of the flow of electric current, my fingers, this is the magnetic field. If this is the direction of the flow of electric current, this is the magnetic field. So always the magnetic field is in the left hand side to the direction of the flow of electric current. Getting it? Does the earth के अंदर का liquid can change the direction? Yes, because it is liquid, and liquid can change the direction anytime. Liquid does not flow in one particular direction. क्यों change कर सकता है? Any events. Suppose a liquid is flowing in this direction जहाँ से volcanic vent is there. Suddenly that vent is closed, and then the liquid will find some other direction to come outside the surface of the on the earth. Getting it? And now because of this, the earth का magnetic field keeps on shifting. यहाँ तक तो standard procedure. Getting it? Understood everyone? That why the earth का magnetic field keeps on shifting? क्योंकि अभी के लिए right on now only for the continental drift theory, remember the liquid changes the direction and earth का magnetic field keeps on shifting. We have an evidence this year itself, that is the earth का magnetic field is shifting to the east. Whatever is the direction, the earth ka magnetic field is shifting more and more to the east. Right now, where is the magnetic field of the earth? The magnetic north pole of the earth is in Canada, and it is now going towards Siberia, towards the Russia region. So if this magnetic pole is shifting, and if this is the north magnetic field, that means south must be somewhere. And agar north is shifting to the east, that means south is also shifting. Getting it? This is how the, so what happens after 1 lakh years, after every 1 lakh year, conditions, why we don't know, but we know the fact. Or maybe after some 1 lakh year, but the recent has 1 lakh year, the earth can not, this is how the north pole and the south pole keeps on shifting, and there is a complete flip in the magnetic field. Flip means north is becoming south and south is becoming north. Of what? Not the earth ka pole, earth ka magnet. Understanding this? There is a complete reversal in the direction of the magnetic field. If this is the north pole, if this is the south pole, it will shift to the east, and then it will one day change the direction. How is it an evidence of the continental drift? That is the question. How is it an evidence of sea floor spreading or plate tectonics? मतलब ये हमें तीनों में आएगा. Sea floor spreading, plate tectonics, how it is an evidence. Evidence is there are numerous metallic minerals present in the earth's crust. They are in the molten form. So that molten form we call it as magma or lava. When that magma or lava comes up and forms the rocks, the metallic minerals are attracted towards the north pole and south pole of the earth. So suppose in this first position, this is the north and this is the south, and this is where the molten rock has come on the surface of the earth and it has melted. It is now solidifying. It is mixture of Cl, सीमा, उसमें आयरन भी है, उसमें एल्यूमिनियम भी है, उसमें कॉपर भी है, उसमें सिलिका भी है, उसमें कैल्शियम भी है. There are numerous minerals that are present inside the earth. Out of that, is calcium metallic? Calcium? Is your toothpaste metallic? No. Iron, is it metallic? So iron will get attracted to the north and south. So the calcium or anything may get solidified, but the iron will always get solidified in the north and south direction, and this is how the iron particles will get solidified. Then over the period of time, suppose this has formed 1 lakh years before, by radiocarbon dating we can study the age of the rocks, and we can when we study the age of the rocks, we study how is the direction of the metallic minerals. If it is in this and this direction, that means that time the magnetic pole was in that particular direction. Now suppose after some years this becomes a magnetic pole. How will be the direction of the freezing of the metals? North and south. This is how the metals will be freezing. That means magnetic pole has shifted. This is one. That is the direction of the magnetic pole gives the direction of the freezing, yes, solidifying of the metallic minerals gives the direction of the magnetic pole. A magnetic pole may be same in some of the rocks. Remember, but magnetic pole may not shift. But suppose this is India, right? And this are the metallic minerals which are formed in India. So in the first position, the inclination of the iron ore will be this way. Fine. Now India has drifted here. Imagine the magnetic pole has not shifted. India has drifted here, and in this direction the metallic minerals will be in this way. India has now shifted here. In this direction the metallic minerals may be more and more inclined. Getting it? And कैसे पता लगता है? Because north of magnet will attract south of metallic mineral, because the opposites attract. Fine. ये है the direction. दूसरा, this duster is a magnet and this is an iron. Imagine, if I bring the iron near this duster, will it be at same position? No, it will get attracted. And if this is the magnet ka north and this is the south, fine, kaise hoga? When it solidifies, it will be attracted towards the duster, and this is how the metallic minerals will be freezing. Getting it? Q? Because poles pay, the power of the magnet is greatest at the poles, and therefore the direction, remember there are two things, one is direction and the other is dip or angle. Have you understood first regarding the direction, everyone? How the direction keeps on changing? Now consider the dip. This is the magnetic north, and this is where the any metallic mineral is freezing. It will now be more or less parallel to the magnetic field, because this will be attracted towards the magnetic field. यहाँ पे also it will be the same, but as it is coming nearer to the magnet, it will be attracted more towards the magnet, and when it comes exactly at the poles, the direction or the dip will not be parallel, it will be perpendicular to the magnet. Why it will be perpendicular? Because power of the magnet is greatest, and therefore this north will attract the south. Understood? Understood everyone? Getting it everyone? So by this we can also know the position of the continents. That is, if now imagine there is some volcanic activity which is going on in Iceland or Greenland. Volcano hai wahan pe. After that the rock freezes. Freezes matlab solidifies. Don't think of cold wala freezes. We use this word commonly in geomorphology also. Solidifies. What will be the dip of the magnetic or metallic rocks in that? Perpendicular or parallel? In the Greenland region, it will be perpendicular. Fine. Now suppose you take the Greenland and move it near the equator, and now there is a volcanic activity. What will be the dip? Perpendicular or parallel? Parallel. This is why we can understand how the equator has shifted, how the position of the poles have shifted. Getting it? And by understanding this, so in 1 lakh years, magnetic pole has not shifted, but in 1 lakh years, still the rocks ka position have shifted because the continents have drifted. Getting it? And this is one of the biggest evidence of the continental drift theory. That is the study of magnetic properties in the old rocks. Fine? So the magnetic property of the earth, getting it, is known as geomagnetism, and the study of the magnetic property in the old rocks is known as paleomagnetism. Why I told you paleo means old. Getting it? So these are the two things you should remember. 150 words के लिए generally ये short note आता है, and this is the most difficult part of the continental drift theory. Getting it? The paleomagnetism and the geomagnetism. So geoscientist or geologist will always study not just कैसे rocks मिलता है, but also how the iron is found in the rocks, so that they can understand what is the dip and the angle as well as the direction of the magnetic field. Suppose we are living now. Suddenly, due to some geological event, north becomes south and south becomes north. So what will happen? From tomorrow, जो भी lava है that is coming up from the surface of the earth. For example, there is only one country in the world, India. fine. And there is a volcanic activity which is going on in the barren island, Andaman and Nicobar Islands mein barren island, there is a volcanic activity. Ab it is pointing to the north and south, that means the south of the iron that comes from the barren island ka volcano will point to the geographical north, and vice versa. Suppose there is a flip ho sakta hai. Flip means suddenly north becomes south and south becomes north, ho sakta hai? Theoretically yes, theoretically flip can occur. Kyun? Outside the scope of human understanding, not just science, it is outside the scope of human understanding. Suddenly the north can become south, south can become north, but what we know, if the flip occurs, that is the end of life on the earth, we just know this. So past events have occurred, that is there has been flip. Kitne saal baad hota hai flip? 1 lakh years. So last flip, when did it occur? 10,000 years before. That is, there are still 90,000 years to go till the next flip is going to occur. Fine. So, but flip process shuru ho gaya? Yes. That is why there is sudden increase now in the speed of the change of the magnet. Fine. January ka news. So suddenly a flip will occur. Then what will the barren island ka jo bhi volcanic rocks hai, they will now freeze, not in this direction but in opposite direction. Getting it? So this is what is the paleomagnetism or geomagnetism. See, remember, geomorphology, very limited understanding. Why? Sources ही नहीं है study करने के लिए. You cannot go inside the earth and study. Whatever the idea we have, हाँ जो theories आई है, and then we have tested the theories, and जो हमें ठीक लगा, हाँ हो सकता है ऐसे, that has become a theory. Fine. So convectional current theory by Arthur Holmes is, yes, one of the things that is responsible for the drifting of the continents. पता चला आगे जाके, a new technology comes, that theory is entirely wrong, a new theory will come. For example, before plate tectonics, the most important theory which we used to study is geosyncline. We will cover geosyncline and isostasy today itself in the lecture. These were the two important theories. Now they are gone out of the syllabus. Fine. But only Indian geography या Asian geography, South Asian geography, not even Southeast Asia. South Asian geography is the only geography which still believes in geosyncline. World over में से, if you buy Stoller and Stoller, ना isostasy is mentioned, ना geosyncline is mentioned, because European geography has discarded those theories. But हमारे syllabus में है वो theories. That's why we study this. For them, the most important theory is plate tectonics, not geosyncline. Getting it? So जो theory discarded है उसके ऊपर question आता है, though it is in the syllabus. Yes, 2018 itself had a question on geosyncline theory. ऐसा नहीं है, क्वेश्चन जो जो सिलेबस में किसी पे भी आ सकता है. फाइन. गेटिंग इट? सो पैलियोमैग्नेटिज्म. वर्ड्स आर डिफिकल्ट, ब्रेक द वर्ड्स, इट इज वेरी इजी. पैलियो मैग्नेटिक मीन्स ओल्ड मैग्नेटिक स्टडी. जियोलॉजिकल टाइम स्केल is divided into Paleozoic, Mesozoic, Cenozoic. Paleozoic is further divided into Cambrian, Ordovician, Silurian, Devonian, Carboniferous, जब वेगनर की कॉन्टिनेंटल ड्रिफ्ट थियरी शुरू हुई, एंड पर्मियन. दिस इज फर्दर डिवाइडेड इनटू न्यूमरस, उसमें एक क्रेटेशियस है. दिस इज फर्दर डिवाइडेड इनटू क्वाटरनरी, सॉरी टर्शरी एंड क्वाटरनरी. Primary, secondary, tertiary and quaternary. So this is the primary, this is secondary, this is tertiary, this is quaternary. Quaternary is further divided into Holocene, and recently last month scientists have decided to the latest epoch when human beings have changed the face of the earth. So the last XYZ years when human beings have dominated the face of the earth and have caused irreversible changes on the face of the earth is what is known as an Anthropocene. Getting it? A continental drift mein, because it started Carboniferous, obviously there was a drifting of the continents. This is Cambrian is 600 million years ago. So imagine how many times the earth must have flipped after every 1 lakh years, fine. So 600 million years means at least how many times? 1 million. Well, how much is 1 million? 10 lakh years. So even if earth is flipping after every 10 lakh years, earth has flipped minimum 60 times. So that is how you can understand the Paleozoic evidence of the rocks. Anthropocene era, ये GS का टॉपिक है. What is an Anthropocene? Why it is known as an Anthropocene? कब से शुरू हुआ Anthropocene? That is, scientists have not agreed to it because there are three debates. Someone says as soon as when agriculture started, that is 10,000 years before. Some say no, industrial revolution when it started, that is because of that we have changed the face of the earth. Some says no, when the great acceleration started. Great acceleration 1940s, जब nuclear energy आई world में. So that we have not yet decided. So ये topics पे याद रखना. Any editorial etc. on the Anthropocene, you should be knowing it. So Paleo, old, Zoic, life. Meso means middle, life. Ceno means new, life. Similarly Paleo, magnetism, old magnetism. New magnetism पढ़ने की ज़रूरत नहीं because अभी तो पता ही है इंडिया कहाँ पे है, fine. So what you will do out of that, right? So paleomagnetism. Paleomagnetism and geomagnetism. Paleomagnetism and geomagnetism deals with the study of Earth's magnetic fields, study of the Earth's magnetic fields, and the presence of magnetic direction and dip, in the fossilized rocks. Fossilized rocks means जो rocks अब solidify हो गए, fine. Fossilized rocks, fossils, FOSSILSED, fossilized rocks are in solid rocks because both the direction and the dip gives an idea of the magnetic properties of the earth, as well as drifting of the continents, Next point, the direction of metallic minerals in the rocks, reveals the direction of the magnetic fields, reveals the direction of the magnetic fields whenever the rocks were formed. Whenever the rocks were formed. Reveals the direction of the magnetic field whenever the rocks were formed. And since the magnetic field keeps on shifting, since the magnetic field keeps on shifting, and the of south of the rock, south pole of the rocks gets attracted towards the geographical north pole, gets attracted towards the geographical north pole. We can understand the shifting, we can understand the shifting of the minerals, sorry, the shifting of the continents, shifting of the continents. Full stop. नेक्स्ट पॉइंट, द डिप और द एंगल. पहले एक पॉइंट था डायरेक्शन पे, दूसरा पॉइंट किस पे है? डिप और एंगल पे. द डिप और द एंगल tells about the strength or the intensity of the magnetic field. The dip or the angle tells about the strength or the intensity of the magnetic field. And since the intensity is greatest at the poles, intensity is the greatest at the poles, the dip is perpendicular if a rock has solidified near the poles. If the rock has solidified near the poles. Full stop. On the other hand, if the rock has solidified near the equator, on the other hand, if the rock has solidified near the equator, the angle is parallel to the magnetic field. The angle is parallel to the magnetic field. You can draw the diagram. Diagrams. एक जनरली पॉइंट के नीचे या पॉइंट के ऊपर बनाओ, सो दैट एग्जामिनर नोज कि आपने क्या लिखा है, वो इतना सब पढ़ते नहीं बैठेगा. Can I continue? Next point. Now the study of past magnetic properties of the rock, the study of the past magnetic properties of the rocks shows that shows that shows that there are some parts of the world, which today are near the polar regions, but have parallel magnetic dip, dip. Which parts we are talking about? कहाँ से जा रहा था कार्बोनिफरस इक्वेटर? जस्ट टर्न सम पेजेस बैक. दैट इज आयरलैंड, स्वीडन, स्कैंडिनेविया. दिस वाज जहाँ पे once upon a time there was equator. Where are this present now? These are present now near the poles. वहाँ पे today the magnet, today whenever there is a volcanic activity, how is the dip? 90 degrees. But if you go on searching, जितना नीचे आप जाओगे, older rock is always present below, new rock is always present at the top. The older rock you find, you will find parallel magnetic fields. Getting it? Getting it? Fine. This means that those continents or those places were once near the equator, and have drifted, underline the word drifted, and have drifted to their present position. Example, North Europe. Similarly, the study of rocks in India, shows that older rocks have perpendicular dip, while the newer rocks or the recent rocks have parallel dip, have the parallel dip. Similarly, the direction of the rocks have also changed. Indicating that India has drifted northwards. indicating that India has drifted northwards. So ये prelims में भी पूछते हैं, paleomagnetic evidences show that India has drifted in which direction? Northwards. Getting it? That is how the dip and the direction has changed. If this was India near the poles, dip was here. It has drifted now to the north. Obviously the dip as well as direction will keep on shifting. Fine? Direction अब वो Canada की तरफ है, because the magnetic pole is near the Canada. पहले direction भी Canada की तरफ था, but India was just below Canada. Now it is much to the east of Canada, and thus the direction has changed. Do you know how to make somewhat three-dimensional diagram? Straight line and then fine. Now understand what I am doing here. This is the ocean floor, and the ocean floor is continuously created and destroyed. क्यों? Sea floor spreading. ये क्या है? This is the margin, mid-oceanic ridge, जहाँ से there is a volcanic activity coming up, and then ocean floor is created and expanded. Now, if I study the ocean floor, I will see somewhat parallel lines. If I just make the magnetic properties, if I just draw the magnetic properties, there's one parallel line. उसके बाद there is another parallel line. Just let me draw this. The same at an equal distance away from here. Now you will study over the period of time. हमें सिर्फ ये लिखना है, अभी explain नहीं करना है, because this is a part of sea floor spreading. Fine. What you understand? This is young rock, this is old rock. ये उससे old है, ये उससे भी old है, and thus as you go away from the center, the rocks keep on becoming older. Now the age of the oceanic crust is somewhere around millions of years, 300 to 400 million years, right? The age of the earth is 4.2 billion years, but the age of the oceanic crust, SEMA, is just 300 million years. That means which is younger? Oceanic crust. What is the age of the earth? 4.2 billion. What is the age of the SEMA? 3 to 300 million. Huge difference between billion and million. Fine. And if I go and studying the magnetic property, I will see that some of these rocks are aligned in north and south direction as of today. उसके बाद मैं जाता हूँ तो this of the rocks are aligned कि उसका north is this, उसका south is this. After that again north, south. After that again north, south. What does it mean? That is, after some regular interval, what has flipped? The magnetic pole of the earth has flipped. Fine. So this is also an evidence of the paleomagnetism, but ये हम अभी नहीं लिखेंगे because there is no evidence of drifting in it. हम continental drift पढ़ रहे हैं, but this is just what I am telling you. This is what is known as magnetic anomaly. Magnetic anomaly. You don't understand कि south becomes north, north becomes south unless you know paleomagnetism. इसलिए anomaly. But once you know कि earth का magnetic field has flipped after every 1 lakh year, fine, then you can know कि yes, ये हो सकता है. That is why north becomes south and south becomes north. Fine. अब ये जो fact है core geography का, the earth's magnetic field flips after 1 lakh year, came in last year's prelims, not in this year's prelims. The only difference was, उसमें line दी थी, Earth's magnetic field flips after 100,000 years. 100,000 years means 1 lakh years. Fine. So there are some facts you should also know. One question of the core geography may come in the preliminary examination. Fine. So no need of drawing this diagram again here. Similarly, why I made you explain? Because of this line. Similarly, The study of oceanic crust also reveals, study of oceanic crust also reveals that there is magnetic anomaly, anomaly, anomaly means mismatch, magnetic anomaly on the oceanic crust. Thus, the study of the old rocks, the study of the old rocks are the biggest evidences, are the biggest evidences of, of dynamic nature, of the dynamic nature in the arrangement of continents and oceans. Dynamic nature in the arrangement of the continents and oceans, and proves that drifting has taken place, proves that drifting has taken place. Drifting, drifting has taken place, drifting has taken place, right? What we are showing, we are showing that drift has occurred or not. So do we know by the direction the drift that drifting has occurred? Yes, direction has changed of the, imagine कि magnetic compass रखा है आपने continent पे, and as India has changed उसका position, the magnetic compass has changed, and now you have taken the magnetic compass near the poles. So the magnetic compass at the poles will not show you north south direction because you are already at the pole. It will show you not in this way, it will show you this way, you are already at the north pole. The same thing is happening in the direction, this thing, that is आपके mobile में there is a compass, it is pointing to the north, magnetic north of the earth. Fine, as soon as you change your position in this room, वो change करेगा अपनी direction. The same thing is happening to the continents, but at much larger scale. Now imagine उस magnetic compass के नीचे आपने proper magnet रखा which is much more powerful than the earth. वो magnetic compass में खराब हो जाएगा, गड़बड़ी हो जाएगी, it cannot show anything. The same thing is happening here. Getting it? The only thing is you have to write a geography का answer by understanding these small topics. Fine? So what is the paleomagnetic evidence? कि आपको सिर्फ geography के answer में लिखना है rocks. And even if you don't remember in the examination, you have not studied anything in the examination, you just have to imagine you are carrying a magnetic compass, you are India, and how you have changed your position, and therefore how the magnetic compass has changed the position. You already know equator has changed the position, so say dip or ek direction. That is the answer. 150 words, khatam. Fine? Fine with this? Next evidence is paleoclimatic evidences, the evidences of the old climatic conditions. So what is the present climatic condition? Whatever may be the present climatic condition. But if you have evidences of glaciation in India, that is कुछ rocks है जिसमें there are evidences कि हाँ यहाँ पे glaciation था. कब था glaciation? Yesterday? No. Some millions of years before. So that is old. So paleo, climatic evidences. So paleoclimatic evidences of continental drift is nothing but We talk here, write an answer regarding the glaciation that has occurred recently or in the old era, in the old era. And therefore we will not write about Pleistocene, because Pleistocene is very recent. We are not going to write about the Pleistocene glaciation. We are going to write about Carboniferous glaciation. Why? Because when did Carboniferous period occur? In the Paleozoic era. Cambrian, Ordovician, Silurian, Devonian, Carboniferous and Permian. We don't write about Cenozoic, recent, tertiary, and tertiary के बाद quaternary. Quaternary क्या एक period? Pleistocene. This is recent glaciation. इसके evidences मिलते हैं तो कोई खास बात नहीं है. Fine. We talk about the Carboniferous glaciation, the old glaciation. Fine. This question has come indirectly only once in the exam. If you look in year 2013, there is a question. Write a 2012 may write a short note on the paleoclimatic evidences of the continental drift. इससे पहले it has come directly as Carboniferous glaciation. अब what happened in 2012? Many people could not answer this question. उनको लगा ये books में दिया ही नहीं है, हम क्या लिखेंगे? Fine, ऐसे कभी नहीं होता कि books में दिया नहीं है. The only heading in the books is Carboniferous glaciation. Fine, but if you can understand why it is known as paleoclimatic evidences, if you look at the era between 2012, 13, 14, 15, to some extent 16, 17 paper was very difficult, but scaling हुई थी 17 में. So in this 5 to 6 years which I am talking, papers are difficult not because it is out of the syllabus. Papers are difficult because instead of normal words they used difficult words. What is a mountain? Mountain can be volcanic. Mountain के ऊपर if there is a crater, it is a volcanic crater. But crater is not formed only due to volcano. Crater may be also formed, we have done an example, due to meteors. Fine. It also looks similar to volcano, but it is not formed due to volcano. इसको हम कहेंगे pseudo volcanic features. So ये उन्होंने पूछा था short note pseudo volcanic features. Fine. The only thing is keep your mind open. Just don't get stuck in the optional कि नहीं मुझे आता ही नहीं है. Don't get panicked there. जो कुछ भी आइडिया आसपास के लिख के आओ, because when the paper comes difficult, obviously the marks are rewarded of whatever you write in the related this thing. If the paper is easy, like this year 2018, marks are cut. Fine, because paper was so easy, you should write exact answer. Fine. So never be happy when paper is easy. Always be happy if you are a good student when the paper is difficult. Because if the paper is easy, it is easy for a person who has studied only 1 month. Fine. Because when the paper is easy, who wins the race? Knowledge does not win the race. Wins the race makeup, diagram, structure. Fine. When the paper is difficult, knowledge will win the race. When the paper is easy, Bollywood जैसा है, makeup और ऊपर का दिखावा will win the race. So now here what we are going to write. Climates have not changed. Climates have remained the same. But you have changed. Ab you are India. You are right now going somewhere near the equator. So you face equator ka whatever the climatic processes are there. Then you come to subtropics, you face वहाँ पे. Then you come to the area जहाँ पे there was glaciation and you face the processes there. So again, what is this? This is the evidence कि आप बहुत जगह घूम के आए हो. That means this is the evidence of drifting. The only thing is instead of you have to write continents have drifted. Fine. So can you start this answer with why we have studied first 3 lecture में laws? Can you put any law here? Geomorphic processes leave their distinct imprint on the landform, fine. And therefore, what is the process? Climate is one of the process. As the continents have drifted, they have gone through different climatic conditions, and therefore we find the evidences of different climatic conditions. Take one example, take an example of India. I told you already there are the evidences of glaciation in India. So mention those evidences. If there are lakes, glaciated lakes which have originated, or there are tillite deposits. Tillite deposits, the deposits of very fine material. जैसे alluvial soil means water है, fine. जैसे sand is there means wind है. वैसे if the till is present, till is nothing but a soil which is very soft, means this area is under glaciation. So tillite deposits are found in the subtropics, that is in India, Brazil, Gondwana, all the regions of the Gondwana land, fine, which means this was once under the glaciation. Because today the glaciation cannot be possible jahan pe Tropic of Cancer and Tropic of Capricorn is passing, but how it is there, which means the continents have shifted the position, fine. Similarly, answer khatam mat karo. Similarly, the evidences of coal in North America, in England, because wahan pe coal will always be formed when vegetation, tropical vegetation, will be buried under the water. Now for the tropical vegetation to be there, there has to be hot and humid climate. Isliye to vegetation is known as tropics. Tropical vegetation means what? One that grows between the Tropic of Cancer and the Tropic of Capricorn, because this is the region which is hot, and therefore hot hai, isliye we will call this as tropical climate. So but today when we study, these regions have high, very low temperature, fine. It is a cold climate, which means once upon a time this region was near the equator, and they have drifted northwards. Conclusion: paleoclimatic evidences as well as paleomagnetic evidences have shown that many of the continents such as Africa, India, and the smaller countries have all drifted northwards, and this is an evidences of the continental drift theory. Getting it? Why we study this theory? If it was so wrong, it should not be in our syllabus. We are studying this theory because it is right theory. So iske baad conclusion hi likhna hai regarding Wegener. So conclusion is, Wegener, though there are many flaws in his theory, Wegener ka biggest credit is he made the scientific community think, and when he made them think, he changed the entire knowledge base, and today we can understand that continental drift is a reality, and the further studies of the continental drift have been in the form of major theory, that is the plate tectonic theory, right? So paleoclimatic evidences. The study of past climates, the study of past climate gives a better idea about the changes in the climatic conditions, about the changes in the climatic conditions, gives a better idea about the changes in the climatic conditions, because geomorphic processes leave their distinct imprint on the landform, leave their distinct imprint on the landform. Full stop. Distinct imprint in the landform. So you should know which law to use where. जैसे climate, देखो कोई process वाला है, don't put structure वाला here, because we have to justify here processes. We don't have to justify here structure. Understanding why we are using this? Don't here justify time, सिर्फ process वाला ही law. सब लॉ राइट है, सब लॉ में रॉन्ग है, हमें सिर्फ आंसर लिखना है. You don't have to prove which law is right or wrong unless it is specifically asked. All these 8 laws are right, all these 8 laws have some flaws. You should know how to write an answer regarding this 8 laws, right? imprint on the landforms and is reflected on them, लिखने की जरूरत नहीं है, वो obvious है. Next point. The past climates have changed. The past climates have changed. Past climates have changed because the positions of the continents were not constant, were not constant, were not constant, and they have drifted from one climatic zone to another. They have drifted from one climatic zone to another. Climatic zone to another. Third point. See, scientific optional, fine. So how we are writing the answer in points. Just write directly in the points. इसमें arguments हो सबकी जरूरत नहीं है unless you come to the human geography. Third point. घर पे जाओगे तो यही points your preparation should be ready like this कि a topic evidences of continental drift, उसमें paleoclimatic evidences आता है, point intro. लिखना मत, सिर्फ लिखना प्रोसेस वाला पॉइंट. यू शुड नो. पॉइंट नंबर 2 इज ड्रिफ्टिंग एंड शिफ्ट ऑफ क्लाइमेट. पॉइंट नंबर 3 कार्बोनिफरस ग्लेशिएशन. पॉइंट नंबर 4 कोल. पॉइंट नंबर 5 कंक्लूजन. You should have such things ready. And how you should make them ready? Give me a blank pages. You should take one page, fold it into two parts, right? And you should write the points here. Next point here, next point here. So your entire continental drift theory should be on one page. Theory, diagrams कौन से आएंगे? Yes, if anything new comes, value addition from current affairs. Geomorphology में there will be less value addition, but climatology में everything will come in the newspaper. So value addition material, fine. So this should be your one file of 60-70 pages in which your entire optional should be broken down. तो ही एग्जाम क्लियर होगी. गेटिंग इट? तो ये एग्जाम क्लियर होगी मीन्स योर डिजायर्ड रैंक. यू मे गेट रैंक बाय एनी अदर प्रोसेस बट इट वोंट बी डिजायर्ड रैंक. एंड एक बार डिजायर्ड रैंक नहीं मिला तो लाइफ फ्रस्ट्रेशन में जाती है. आई हैव अ फ्रेंड हु गॉट कस्टम्स एंड इज नॉट फिटिंग इन द कस्टम्स बिकॉज ही केम टू दिस सर्विस विद अ डिफरेंट आइडिया. यूएस का जॉब वो सब छोड़ के आया था. सो मनी वॉज नेवर हिज इशू. He already comes from the family of Nawabs in Lucknow. So money for him is not an issue. उसको कुछ तो चाहिए था कि for the society, fine. So he even today he takes 1 rupee as a token salary, donates it to the government. Salary नहीं लेता हो. So because money is not an issue for him, fine. So I have told in the previous batch also कि he does not stay in the government quarter. He is right now posted in Bombay and Bombay में उसने अपना private bungalow लिया है. Bombay में private bungalow nobody can afford, fine. So he stays in that private bungalow with all his servants etc. But he got into the service in 2012. इस साल का भी attempt दे रहा है. क्यों? IAS मिलने के लिए, fine. 13, 14, 15, 16, 17, 18, 19 2 साल तो जॉब किया, गॉट इनटू द सर्विसेज अर्ली एंड 2013 से 15 से फ्रस्ट्रेशन आना शुरू हुआ. 15 का अटेम्प्ट दिया, 16 का दिया, 17 में नहीं दिया, 18 का दिया, अब लास्ट अटेम्प्ट दे रहा है 19 का. यू शुड नॉट बी लाइक दिस. मीन्स दिस इज समटाइम्स व्हाट हैपेंस. इधर यू एक्सेप्ट द रियलिटी और ठीक है, मतलब एक्सेप्ट द रियलिटी नहीं हुआ यूपीएससी में. I should not get frustrated and now give my entire life to state services because attempt तो रहेंगे 45 तक, fine, state services में. But then or you should work that time so hard कि you should not regret at all कि ठीक है I gave my best. मैंने जो तरीके थे माइक्रो नोट्स भी बनाए थे, नहीं हुआ मेरी गलती नहीं है, मेरे नसीब में नहीं था. मतलब वो रिग्रेट नहीं होना चाहिए कि शायद मैं अगर ये अटेम्प्ट में ऐसे करूँगा तो मेरे को ये रैंक मिल सकती है. You have to finish the chapter. So that is why these are the small things. And take down the carbon. Third point. The third point will be regarding the carboniferous glaciation. One of the biggest evidences is carboniferous glaciation. Carboniferous glaciation, in which Wegener prepared a map showing evidences of glaciation, in the form of tillite deposits, Tillite, a soil that is left by glacier. कुछ लिखने की जरूरत नहीं है. Tillite deposits in Brazil, Falkland Islands. Where are the Falkland Islands today? South America. If you look at the map of South America, at the end of the map of the South America, you will find a small island and it is known as an Falkland Island. आज भी वो ग्लेशियर में ही है. So Falkland Island, Africa, Peninsular India, Australia, and Antarctica. Right? Wegener suggested that this region have glaciers or evidences of glaciation, because during that time the South Pole was located near the present day Durban, कहाँ पे है डरबन? साउथ अफ्रीका, present day Durban, and all these continents as a part of Gondwana landmass were located near the South Pole. All these continents as a part of Gondwana landmass were located near the South Pole. And therefore the processes operating in this region, were the processes that operate during the glaciation, were the processes that operate during the glaciation, and hence we have evidences of till till glaciated fossils as well as some of the glaciated topography such as arets, cirque, अभी सिर्फ इतने नाम लिख लो, etc. Arets, cirque, etc. Fine, and draw this diagram. Not this one. This is what Wagner had showed. We are going to draw a simple diagram here. This is how was the Gondwana landmass. Fine, and this is what we mean by the jigsaw fit of the continents. And then this is how they drifted. ये westwards, ये northwards, ये यहीं रह गया. This is how they drifted. Fine. Doubts here? ऐसा नहीं कि डायग्राम हैज टू बी वेरी एग्जैक्ट, बट लगना चाहिए इंडिया है, ऑस्ट्रेलिया है. राइट, डायग्राम हैज टू बी डायग्रामेटिक बिट. This is a region, you know, in the news also, and you know also, this is a region very hot, humid, monsoon type of climate. And what do we find? Evidences of glaciation in the past. Fine. इसमें हिमालय का एग्जाम्पल मत लिखो क्योंकि कार्बोनिफरस पीरियड में देयर वाज नो हिमालयस. Now can I continue? Next point. Similarly, the present distribution of the coal, shows that most of the coal fields of the world are located in Eurasia, coal was formed in a period, ये भी GS के लिए भी याद रखना, the coal was formed in a period known as Carboniferous period, due to death and decomposition of vegetation belonging to hot and humid climatic conditions. But Eurasia, does it have same climatic conditions today? Hot and humid? नहीं. Eurasia does not mean अभी South Asia. Fine, South subcontinent अलग है, हमारे ऊपर वाला region. But Eurasia does not have such climatic conditions today. Which means that the present Eurasia once crossed the equator. Or was present between 5 to 35 degree north, during the Carboniferous period. And today has drifted further northwards. Today has drifted further northwards. Critical analysis of his theory. So what is the critical analysis? Today has drifted further northwards. What is the critical analysis? When we talk about positives, इतने सारे positives है. We also tell the negatives, ये सारे negatives है. उसके बाद हम conclusion देते हैं. That is what is known as an critical analysis. So what is the critical analysis of his theory? Was he completely right? No. Was he completely wrong? No. There are evidences to show yes, drifting has occurred. But where was he wrong? In some of the facts, that is flaws in his theory, forces etc. है. Fine. उसका रीजन ये है, इफ यू रीड स्टैंडर्ड बुक्स यू विल अंडरस्टैंड. ये सविंद्र सिंह नहीं, If you read the thinkers का book, you will understand कि Wagner was more like an advocate. Advocate क्या करता है? Advocate ये नहीं देखता कि reality क्या है, what is the false. Advocate के जो points है उसके लिए evidence gather करता है, जो उसको नहीं चाहिए वो evidence he throws it away. So why? Because I told you Wagner was not a scientist as such कि साइंटिफिक प्रिंसिपल फॉलो करेगा. ही वॉज बेसिकली एन एडवोकेट. उसने वही एविडेंसेस दिखाए साइंटिफिक कम्युनिटी को. ही शुड ओनली दोज एविडेंसेस by which his theory was to be accepted. So his theory got accepted in 1912 to 1924. But when people realized कि ऐसा कुछ नहीं है, in 1924 his theory was rejected. Then came 1940s when US Navy was working on building up a telegram communication lines between North Atlantic and that is between the West Atlantic and East Atlantic. They thought कि आराम से telegraph line will be laid down because ocean तो flat होगा नीचे से. But when they went below the ocean to lay down the telegraph line, they saw कि ocean is not flat. It is having something mid-oceanic ridge. It is having mountains. Then they calculated the age of the oceanic crust. They found it is very new. They also found that Atlantic is drifting westwards, and over the period of time there was regeneration of the interest in the continental drift theory. Regeneration of the interest till that time came Arthur Holmes, who gave convectional current theory कि why the earth moves, जो मैंने कल आपको बताया था कि there is a hot magma below and which gives out steam and therefore the earth moves. So due to all this came the plate tectonic theory, and the plate tectonic theory is Wagner 2.0. That is the new version of the Wagner's theory. Getting it? This is what is the conclusion. Understanding? ये नहीं. Plate tectonic theory सब कुछ यही कहता है. What Wagner says, the only thing is in a proper refined manner. So conclusion, critical analysis. Though Wagner's theory had many flaws, still the basic idea of the Wagner that continents continuously change the position led to serious thought and discussion about the drifting of the continents, comma, studying of seafloor spreading, which ultimately resulted into grand theory known as plate tectonics theory. Grand theory known as plate tectonics theory. Grand can be one of the biggest theories known as plate tectonic theory. Wagner could not explain about volcano, it explains. Wagner could not explain about the position of the continents, it explains. Wagner divided world into Sial, Sima and knife. This divides the world into lithosphere and asthenosphere. Wagner could not explain about the hotspots. Plate tectonic also cannot explain about the hotspots. यही एक negative है of the plate tectonic theory. Wagner could not explain why the fold mountains. This also explains why the fold mountains. Any basic idea about the plate tectonic theory you have? There are convergent plate boundaries, there are divergent plate boundaries. ये सब क्या है? Plates. Wagner सिर्फ उसको कहता था continents drift. वो कहता है इसको plates. Fine? So that is why grand theory. You will understand this when we will develop. But this is how world has progressed over the period of time. सबसे पहले 1912 में continental drift theory 1912 rejected. Then sea floor spreading theory, Harry Hess का 1940s में, and ultimately plate tectonic theory in 1960s. So he talks about drifting of the continents, they talk about drifting of the sea. This is movement of the continents, this is movement of the sea. दोनों को combine कर दिया और बन गया plate tectonic theory. Fine, so it is nothing but in that approach only. Can someone tell me the formula of gravity? Formula of gravity. Mass G is equal to m by, so mass, forget about other things, and r is down or r is up, down. So gravity is directly proportional to the mass. जितना ज़्यादा mass उतना ज़्यादा gravitational pull, and जितना distance उतना less gravitational pull. Fine. So gravity depends upon the mass. Where is the mass maximum? Surface पे या core में? Core में. So the gravity is maximum inside the core. Now, anyone here from civil engineering? What do the civil engineers do? Civil engineers will, you must have seen, whenever they measure the gravity of any area, or whenever they want to level the road, or if they want to level an area, वो किसी instrument से देखते हैं, right? To see how undulations are there. Then they will level that area. और level हुआ कि नहीं वो instrument से भी देखेंगे, and एक ball भी रहेगा उनके पास. And if that ball is constant, that means yes, proper the center of this center of this gravity is this part. Or for example, this pillar is here, why it is not here, why it is not at certain distance, why this pillar or why these beams are at one particular position? Because it is designed, this building is designed in such a way कि this pillar is taking the weight of entire material. Had this pillar been here, it would not have been possible to take the weight of entire material, building would have collapsed any time. We can change anything in the classroom, but we are not changing the pillar. Fine? Why itne bade classroom mein we have big classroom but we cannot change the pillar, or we have a big classroom, we could have easily broken this also, we could not do that. Why? Because this is the center of gravity. If you remove that, pura building ka structure and the building will collapse. So whatever the building collapses jo hota hai, generally we see civil engineers are punished, or the BMC ka engineers, or any of this DMC and DMC ka engineers are punished because they will allow the structures on the hotels. They will not find, they will allow it knowing that उन्होंने main pillars break किए. This is beam and this is the pillar. बाकी का तो सब ये ढांचा है. You can change anything, but you should not change these positions. Fine. Similarly, the earth has the gravity, and gravity depends upon the mass. Now there was a person who came to India and decided कि if he started suspending a blom means which measures the center of gravity, उसको एक धागा होता है and there is a big iron ball. It will always, this blom will always point at the center, and this is the center of gravity. CG I am referring to. Fine. So imagine एक blom लिया मैंने and I am suspending it here. And if this blom can get attracted to the gravity, and gravity is getting attracted towards the mass, understand this is, ये सब answer के लिए ज़रूरत नहीं है, concept के लिए है. If this gravity is getting attracted towards the mass, which is a huge thing in this room, the pillar. So maybe my instrument which is measuring the gravity, it will get attracted towards the pillar because वहाँ पे mass थोड़ा ज़्यादा है as compared to the room. Getting it? Now there was This may get attracted or may not get attracted. By my calculation, this should get attracted, but in real life the results may be different. There was a person known as Sir George Everest, जिसके ऊपर Mount Everest is named. Fine. He came to India as the Surveyor General of India. That is one of the Chief of Geological Survey of India. And when he came to India, he saw that there is such a huge mountain known as Mount Himalayas and Mount Everest. देख के बहुत ज़्यादा imposing लगता है, ऐसा लगता है बहुत ज़्यादा mass है. Fine. Understanding? So he thought कि Indians के ऊपर 110% there will be some impact on the gravity, or Indians may be pulled, or there will be the impact of the Himalayas and the Mount Everest on India or on the people of India, because this is such an imposing mountain. It may be obviously pulling the center of gravity towards itself. So he calculated कि if this is my ideal position of the center of gravity, due to the pull of Mount Everest, is it looking more like a center? So if this is my ideal position of the center of gravity, due to the pull of Mount Everest, my instrument will get deflected where the Himalayas are located. So if the Himalayas are located in the north, and if this is my north, this should be my calculation, because उसमें शायद इतना mass हो सकता है sorry, and therefore my instrument may get deflected theoretically at the position known as CG1. Getting it? He calculated at home. He took the mathematical calculations and said, if this is the ideal center of gravity, if the region is very, very flat, now due to the imposing mountains such as Mount Everest, the center of gravity का जो instrument है, it should get deflected to the Mount Everest. कितना deflection होना चाहिए? He calculated something based on the calculations, and he said this should be the deflection. Then he came to India and measured the deflection, and when he measured the deflection, the actual deflection was much less. This should be the ideal position, and this was the actual position. What does it mean? Why the deflection was less? Why the deflection is less? Why Himalayas could not pull the bloom towards itself, to the instrument towards itself? Because ऊपर से तो बहुत बड़े दिख रहे थे Himalayas, but उसके अंदर इतनी density नहीं थी. They were not having that much mass and density कि they can impact the gravity. Then similar studies were done in Rockies. Similar studies were done in Andes, and ultimately they saw कि variation नहीं होता, and therefore we come to the concept of isostasy, that how much is the attraction of the particular place on the earth. So can I conclude by this, because Himalayas are not attracting my instrument like this, means जो दिखता है वैसा नहीं Himalayas, अंदर से Himalayas खाली है, they are hollow from inside. वो सिर्फ बाहर से दिखते हैं बहुत बड़े. For example, you go to the market anywhere, you go to the Archie store etc. बड़ी मूर्ति होती है, ऐसा लगता है बहुत भारी होगी, जब उठाने जाते हो खाली होती है. Why? It is very light, क्योंकि it is just an ऊपर, it is made up of plastic, अंदर कुछ भी नहीं है. और वही मिट्टी की मूर्ति छोटी भी हो तो बहुत, it is very heavy. Why? Because it is not hollow. So if something is hollow from inside, it will be not heavy. So this conclusions were come that Sial is lighter than the Sima, and the lightest rocks float on the Sima. So jitna high the mountain, it means it is made up of more lighter rocks, and this is the concept of isostasy. Of how the lighter rocks we are going to study in this two parts, that is in the concept of Sir Airy and the concept of Sir Pratt. Are they relevant today? Yes, they are relevant today. Why? if you make the dam made up of very high rocks, very strong rocks, it is going to surely cause an earthquake. So you will make a dam, but if you make a very big dam and continuously store the water, what the water will do? It will, if this is a dam and if I continuously store it with water, it will compress the crust of the earth, and it will compress to such an extent that one day ultimately the crust will break, and if the crust breaks, नीचे से rocks हिलेंगे and it will result into earthquake. So you have studied, you have a general knowledge, जहाँ जहाँ बड़े बड़े dams है, there are earthquakes. The concept is isostasy. Getting it? How much वजन होना चाहिए, how much the weight can be. Why? जितनी बड़ी building उतना deeper has to be basement. Fine? This is what is the concept of isostasy. Everyday examples, but we study only in the terms of theory. Sir George Aryan, Sir Pratt. Fine? If you go Savindra Singh, there is a concept of Jolly, there is a concept of 7 or 8 scientists. वो नहीं करना है, हमें सिर्फ एरियन प्रैट पे रुकना है. फाइन. सो आइसोस्टेसी. Now imagine this platform is made up of liquid inside. फाइन. एंड इसके ऊपर जो कवरिंग है, इट इज मेड अप ऑफ प्लास्टिक. एंड जैसे अगर मैं ये प्लेटफॉर्म पे चलूंगा, विल आई बी पुटिंग मोर प्रेशर ऑन द लिक्विड, एंड विल द लिक्विड गेट डिस्प्लेस्ड फ्रॉम वन पोजिशन टू अनदर. फाइन. जहां जहां वेयर आई विल पुट माई फिट, wherever I stand, wherever I put pressure, वो liquid will get displaced. Same thing is happening. Crust के नीचे is the asthenosphere. The more you put pressure, the liquid gets displaced. Liquid gets displaced, उनका direction gets displaced, and therefore what changes is the magnetic field of the earth. Understanding this concept? So the theory of isostasy. Do you use the theory of isostasy in your everyday life? Yes. Why? When you are standing or when you want to balance, you will stand like this. क्यों एक पैर पे balance नहीं रख सकते? Center of gravity. Getting it? The center of gravity. This is nothing but isostasy means equilibrium, the position of equilibrium, the position of balance. If that is disturbed, then there may be different problems. What in your body is the center of gravity? Spinal cord. Getting it? If the spinal cord gets displaced, फिर आप चल नहीं सकते. The same thing, because the center of the gravity may be displaced. So the isostasy introduction. There are different physical features. There are different physical features such as mountains, plateaus, plains. On the surface of the earth, on the surface of the earth, which vary greatly in size, which vary greatly in size. Full stop. See, there is ocean, there is mountain, there is plateau, earth is rotating, yaad rakhna, earth is revolving. Now imagine yourself on the merry-go-round, and if I rotate the merry-go-round very fast, you may be thrown away. But ऐसे कभी earth में नहीं होता कि mountain is being thrown away and hitting, पानी कभी thrown away and hitting you. Ocean के अंदर पानी है वैसे ही, though the earth is rotating. Mountain is at that place only, though the earth is rotating. You are not thrown away somewhere on the moon, though the earth is rotating. Why? Equilibrium. Fine? So, in spite of these variations, these features are balanced, or are in equilibrium. These features are balanced or are in equilibrium. Features are balanced or are in equilibrium. This study of equilibrium, or the state of balance between the upstanding parts, between the upstanding parts, between the upstanding parts and the low-lying basins. Mountain, upstanding part, low-lying basin, oceans. Between the upstanding part and the low-lying basins is known as a state of isostasy. A state of isostasy. What is the state of isostasy? Balance between up and down parts on the rotating earth is equilibrium or isostasy. The term was first given by, isostasy में ये नाम आना ही चाहिए. The term was first given by isostasy was first given by Dutton. Was first given by Dutton to determine the state of gravitational equilibrium between the different relief features, the state of gravitational equilibrium between the different relief features. Different relief features on the rotating earth, full stop. How I know that, or how geographers know that Aravallis were once as high as Mount Everest? What does the law of flotation says? Law of flotation says 9 parts are below the earth. If one part is floating, that means 9 parts will be below. That is, if a ship is floating or if a wooden log is floating, this is the water, 1 part will be on the top, 9 parts will be below. Fine? Right? Iceberg, when it is floating, only little part of an iceberg is seen, but iceberg is going deep inside the water. That is the law of flotation. If you throw a wooden log inside, only certain part will float. So jitni boat upar dikhti hai, jitni ship upar dikhti hai, usse 9 parts below it is there. Otherwise, why the ships cannot reach Kolkata? वो तो सिर्फ ऊपर का ही पार्ट है. No, it is 9 parts deeper. That is the law of flotation. Similarly, जितना high the mountain, उतना 9 parts is deep is उसका roots. Maybe it is true, maybe it is not true. Fine. उसका 9 parts deep it is roots. So if the height of the Mount Everest is 8 kilometers, then can I say 70 kilometers deep is the root of the Mount Everest? 9 parts. 9, if one part is reflected up, is seen above the water, it means 9 part is below the water. Fine. The total 10 parts are there. So if Mount Everest is floating on water nahi hai, but seema hai, nothing, no difference is there. The law of physics are same everywhere. So if the Mount Everest, what is the height of the Mount Everest? 8.5 kilometers. 8.5 into 9 or into 10 karo. For simple, that means 85 kilometer deep is the root of the Mount Everest. So when you study the root of the Aravallis, the root of the Aravallis is somewhere around 60 to 70 kilometers deep, which means, but आज उनकी तो height तो इतनी नहीं है. Why height is not there? Because external forces have removed it. But external forces cannot remove anything which is below the earth. They will remove only up to base level. Remember, only the height of the Aravallis is the root of the Aravallis is very, very deep, as equal to the root of the Himalayas. But unka height is very small, which means once upon a time, Aravallis were as tall as the Himalayas. Getting it? So if you go deeper below, you will see there is a root of the Aravallis. Fine? Now if imagine again me and imagine this as a water body, this platform as a water body. I'll put a pressure on the water. The water will get compressed, but क्या मेरा पैर में इतनी ताकत है कि I can compress the water right up to the ground, or will I be able to compress the water only up to a certain height, certain depth? Only up to a certain depth. For example, जब आप गद्दे पे खड़े रहते हो, when you stand on the mattress, you are compressing the mattress entire उसका 6 inches का thickness या only some 1 or 2 inches at the top? Only 1 or 2 inches at the top. You cannot keep on compressing the mattress and mattress में गड्ढा हो जाए and you are touching the bed. You do not have that much power. Why you do not have that much power? You do not have strength. Why? Because you are not iron. यही आयरन की मशीन लाओ, it will compress the mattress. यही logic है isostasy. The higher the mountains, it is made up of weaker rocks. Weaker नहीं, less dense rocks. While the lesser is the depth of anything, it is made up of more denser rocks. And all these rocks, mountains or plateaus or etc., they will compress the surface of the earth. But this compression will not be directly till core. It will be only to a certain depth. That depth can be 80 kilometers, that depth can be 90 kilometers, that depth can be, we'll study kaun sa kilometer. So they will compress. The earth is to 6,371 or 6,400 kilometers deep. So ऐसे कभी नहीं होगा, Mount Everest is standing, इसलिए earth has got compressed and you can see the core. It will get compressed only to a certain depth, and that depth is known as the level of compensation. You cannot put more pressure on the earth beyond the level of compensation. Getting it? So what is the level of compensation? You stand on the mattress, जहां तक आप दबा सकते हो mattress को, that is the level of compensation. Fine? So अब आपको replace कर दो Mount Everest से and mattress को replace कर दो crust से. That is what is the level of compensation. Fine? So one point here. According to Dutton, the higher features such as mountains are made up of rocks of lower densities, while the lower features such as ocean basins are made up of rocks of greater densities. Are made up of the rocks of greater densities. This also we already know. That's why हम इतना confidently कहते हैं Sial is less denser than Sima, or Sima is more denser than Sial. Greater densities. Sima is more denser than Sial. क्यों हम कहते हैं? Sima is ocean basin. Fine. अगर किसी ने आपको पूछा कि पानी हमेशा ओशन से माउंटेन की तरफ क्यों नहीं जाता, माउंटेन से ही ओशन की तरफ क्यों जाता है? Why water flows from land to the sea, not from sea to the land? Answer is simple. Water always flows from greater height to lower height. Oceans are always at lower height. Why the oceans are always at lower height? You get an answer here. क्योंकि ocean is made up of denser rocks, and therefore denser जितना है उतना height is less. Mountain is always made up of lighter rocks, and therefore the height is more. Getting it? Next point. the below a certain depth, below a certain depth, the pressure, the pressure along the horizontal plane is uniform everywhere. Below a certain depth, the pressure along a horizontal plane, horizontal line और plane, जो मैंने आपको कहा मैट्रिक्स का एग्जांपल, is uniform everywhere, and this is known as the level of uniform pressure. This line is known as level of uniform pressure, or better known as, or better known as level of compensation. Level of compensation. Fine. So this is the basic regarding the isostasy का concept. That is how the equilibrium is maintained on the rotating earth. Kitna pressure the rocks are going to put, kitna pressure the mountains are going to put, and kaun se depth tak it is going to put. Now there are two contrasting views. One is of Airy, one is of Pratt. Very easy concept, much easier than what we have studied up tak. Paleoclimatic and paleoglacial से तो बहुत easy है. Background थोड़ा बहुत आपको बताना चाहिए. Yes, you should know what is the background, what story I told you regarding the George Airy and Pratt. I will make you write in very small, only for the answer point of view. अगर वो भी पूछा है तो, but generally UPSC will ask you discuss or compare and contrast the concept of Airy and Pratt. So you should start with Dutton, and you should not write what I am dictating now. It is just for academic interest. But those who want to know what is this, you can go home, you can read the Savindra Singh and get an idea. But again, it is not for our syllabus. ये जॉर्ज एवरेस्ट ने क्या किया, किसी ने क्या किया एंडीज में, ये सब हमें नहीं, हमें डायरेक्टली एरी एंड प्रैट के पास आना है. क्योंकि प्रॉब्लम इज कि व्हाट इज द लेवल ऑफ कंपनसेशन. एवरीवन एग्रीज कि हाँ, द रॉक्स आर मेड अप ऑफ लाइटर डेंसिटीज, हायर रॉक्स. प्रॉब्लम इज क्या है लेवल ऑफ कंपनसेशन. इज द लेवल ऑफ कंपनसेशन यूनिफॉर्म और इज द लेवल ऑफ कंपनसेशन नॉट यूनिफॉर्म. क्यों है ये? Wait for the chapter to end, you will understand why we study this in our daily life. Where will you apply? कि कितना डीप बड़ा डैम होना चाहिए, कितना छोटा डैम होना चाहिए, कौन से रॉक्स यूज होने चाहिए डैम में. फाइन. जितनी टॉलेस्ट बिल्डिंग उतनी सीमेंट की होनी चाहिए या फ्लाई ऐश की होनी चाहिए. फाइन. आंसर इज फ्लाई ऐश. जो टॉल बिल्डिंग है, दे आर जनरली मेड अप ऑफ फ्लाई ऐश, because cement will put extra load and thus it will depreciate much faster. Fly ash will not put extra load. So आजकल जितने भी नई buildings है, they are made up of fly ash mixed with some kind of an cement. So इसलिए what we see in the earlier days, building या घर बनाने में एक साल 2 साल लगते थे. अब building is formed in months. They will come, they will first form a pillar, उसमें concrete भरेंगे, and after that they will assemble the structure somewhere else. They will just come and assemble it. Hey, first floor, सेकेंड फ्लोर, थर्ड फ्लोर, फोर्थ फ्लोर, कहीं और मैन्युफैक्चरिंग हो रहा है, यहाँ पे सिर्फ असेंबली हो रहा है. सो जितने टॉल बिल्डिंग्स है, दे आर ऑल असेंबल्ड, दे आर नॉट कंस्ट्रक्टेड. पहले के ज़माने जैसा नहीं है, दे आर जस्ट असेंबलिंग. सिमिलरली मेट्रो के पिलर्स कंक्रीट से बने हैं, ऊपर के प्लेटफॉर्म्स आर असेंबल्ड, दे आर ब्रॉट इन एंड असेंबल्ड. सो यू शुड नो, once the metro pillar was constructed, metro line या overbridge बनाना is not that difficult. What is difficult is pillar, because pillar is made up of concrete. उसके बाद तो सिर्फ लाके प्लेटफॉर्म असेंबल करने हैं. फाइन. पिलर कितने डिस्टेंस में होना चाहिए? आइसोस्टेसी, where the center of gravity will be maximum. Getting it? जो ये प्रिंसिपल फॉलो नहीं करता, then it becomes दिल्ली का बेस्ट एग्जाम्पल. That is, what is the famous bridge in Delhi? One who is from local in Delhi, जहाँ पे सबसे ज़्यादा एक्सीडेंट होते हैं आजकल. There is a famous bridge in Delhi, which is a bridge that is held by Signature Bridge. I am talking about the Signature Bridge. Signature Bridge is the bridge in Delhi that is not following this principle. It has brought the pillars and pillar के बाद there is Yamuna में you cannot have a pillar. So what they did, they built a cement concrete, and after that वो पूरा bridge को उन्होंने, they have, see, if I want to hold this anything, I should suspend it from down. If I cannot have a pillar, then I should tie it. अब tying के लिए I require ropes. अब duster को I can use threads, but वहाँ पे ropes are made up of iron because this bridge will be used for vehicle transportation. Example is London Bridge. Example is Howrah Bridge. Why there are so many ropes going on? The same we have Signature Bridge in Delhi. It is known for the accidents not because of any structural problem. It is known for the accidents because of the selfie problem. People want to go there and take a selfie on bike, etc., and they fall in the Yamuna. Fine. So the Signature Bridge. Signature Bridge was supposed to get completed 5 years back. It got completed this December 2018. वो calculation mistake हुआ था due to isostasy. You will understand this over the period of time. So the background. Again, background, no need of writing in the exam, only just mention. So all the land masses have mass and exert gravitational force. All the land masses have mass and exert the gravitational force. And because of the gravitational force, they influence plumb bob. They influence plumb bob. जो इंस्ट्रूमेंट का नाम मैं कह रहा था, that is the plumb bob. They influence the plumb bob that measures the center of gravity. And is used in leveling and surveying of the land. Used in leveling and surveying of the land. See, have you, any one of you installed, have you seen आपके घर में LCD या AC install होते हुए? Nowadays they don't bring the plumb bob. They bring a small tube जिसमें there is a mercury. That is the same thing. Then they will put it here. Though ये दीवार हमें सीधी लगती है, but if I put it here, जरूरी नहीं ये दीवार सीधी है, छत ही टेढ़ी हो सकती है. The roof itself can be slanting. So the TV has to be properly straight. Otherwise you cannot watch the TV at an angle. It has to be straight. So what they do? They will take it parallel from the roof, and they will install the screws only where the mercury is exactly at the center. If the mercury is away from the center, that means it is not the center of the gravity. Fine? Say, everyday life mein hai iska examples. The only thing is, when you study those concepts, you find it difficult. When you use it in daily life, you find it very easy. Fine? That is what is the isostasy. So, next point. Choice is yours if you want to write him. No need of writing, but मैं लिखा रहा हूँ because he was the first one to measure. Perry Bauger found anomaly, मतलब mismatch, anomaly or discrepancy you can write, or discrepancy in the deflection of plumb bob, between the calculated value and actual observations, between the calculated value and actual observations. Actual observations in Andes, in Andes, in Andes. The same thing happened in Andes. This should have been the calculated value, this was the actual observation, fine. The deflection was much less. Similar observations were seen in India. Similar observations were seen in India. When the survey was done under George Everest, when the survey was done, the George Everest, George Everest, right? George Everest in मतलब उसका starting should be capital. George का survey was done by George Everest between the gravitational pull of the Himalayas, of the gravitational pull of the Himalayas, of the gravitational pull of the Himalayas between Kalyana, a place between Kalyana, it is nothing but a place in MP, in Himachal, Kalyana, and Kalyanpur. And Kalyanpur. If this is our India, क्या है ये? Great Himalayas, Middle Himalayas, Shivaliks, Kashmir, Leh Ladakh, then Great Plains, and then Peninsular Plateau. So just for your knowledge, if you want, कि क्या है ये Kalyanan. So he calculated how much is the deflection. He calculated here how much is the deflection. यहाँ पे deflection came to the more or less the same. Actual जितना deflection होना चाहिए उतना ही था, उससे थोड़ा कम था. But यहाँ पे deflection was very less. Why? Because यहाँ पे the deflection was more or less same as per the calculation, because gravity is dependent upon inversely proportional to distance. So as he moved away from the Himalayas, the effect of the Himalayas was not there. किसका effect था? Plains का और plateau का. And this plain or plateau is made up of denser rocks, and therefore the deflection was recorded as per the actual value. But यहाँ पे whatever he must have thought, if this is Himalayas, the density must be very high. That means he had done wrong assumptions regarding the density of the Himalayas, and therefore the deflection was not there. So what is the conclusion? Higher the rocks, less density. Flatter the rocks, more density. Fine? Kalyana and Kalinpur. Not needed. This was just to explain you. See, the deflection differed by in the terms of 5.5 degrees, where 1 degree equals 200 meters. मतलब 5 डिग्री से कम ज्यादा डिफ्लेक्शन हुआ. अब यू से ओनली 5 डिग्री से कम ज्यादा इन 360 डिग्रीज, डज इट हैव एनी इम्पैक्ट? यस. डिफ्लेक्शन ऑफ 5 डिग्रीज का रॉन्ग मीन्स 1 डिग्री इक्वल्स 200 meters. So 5 degree equals समवेयर अंडर टू 1 किलोमीटर का डिफरेंस. दैट मीन्स मेट्रो पिलर जहां पे होना चाहिए उससे 1 किलोमीटर गलत जगह आप लोगे, क्या होगा? एंटायर मेट्रो विल कोलैप्स. फाइन. सो इट इज नॉट, वो छोटा डिफरेंस है बट इट हैज अ ह्यूज इम्पैक्ट. फाइन. सो नेक्स्ट, the Sir Everest concluded, the Sir Everest concluded, Sir Everest concluded, along with Sir Everest and Sir Pratt, Sir Pratt concluded, दोनों ने conclude किया, concluded that Himalayas were made up of, Himalayas were made up of much lighter sialic material, much lighter sialic material, and hence there is discrepancy, hence there is discrepancy in the gravitational attraction of the Himalayas. Himalayas. There is discrepancy in the gravitational attraction of the Himalayas. The reasons given were, the reasons given were, one, first reason. उन्होंने what is the conclusion? Is the Himalaya का gravitational pull more or less than the theoretical value? It is less. So they gave the reasons why the gravitational pull is less. First reason, Himalayas are hollow mountains. Himalayas are hollow mountains and have bubbles inside. And have bubbles inside. कुछ भी foolishness, मतलब अब 1860s की theories है. Have bubbles inside. मतलब अंदर हवा भरी है, not rocks. Right? Have bubbles inside. And therefore they exert much less gravitational force. Exert much less gravitational force. But majority of the scientists rejected this view. But majority of the scientists rejected this view. क्यों? Can you imagine a rock mountains such as Himalayas have bubbles inside? No. Then second reason they gave, second, rejected this view. Second, Himalayas are made up of rocks. Himalayas are made up of rocks which have low density and therefore their gravitational pull is also low. Gravitational pull is also low. Now, do Himalayas have petrol inside? Are Himalayas extremely rich in petroleum? Yes. Then why do India import the petroleum? Why don't we mine the petroleum? Hmm? It is not easy to explore, and secondly, if you remove the petrol, क्या रह जाएगा अंदर? Bubbles. Entire mass of the Himalayas will collapse, and it will result into earthquakes. Getting it? Why we are not exploring, though we are sitting on one of the richest deposits of petrol in the world? Because it is said that Himalayas, because it came out of the Tethys Sea, 100% there is petrol. But imagine if you are removing the petrol, there will be bubble. Himalayas will collapse, and if the Himalayas will collapse, earth will shake and India will suffer, Nepal will suffer. There will be so great intensity earthquake, maybe North India will be destroyed. So therefore, mineral exploration of the Himalayas cannot be done. Isostasy. You don't have to disturb the center of the gravity of the Himalayas. Otherwise, Indian plate को स्पीड मिल जाएगी. इंडियन प्लेट जो नीचे है वो ऊपर की तरफ आएगी. ऊपर की तरफ आएगी तो एंटायर इंडिया विल शेक. एंड व्हेनेवर अर्थ शेक्स, दैट इज द earthquake. Earthquake का एक रीजन इज प्लेट टेक्टोनिक्स, but there are numerous reasons of an earthquake. Fine. But there are two views here. One is of Airy. First we'll do Airy. Very easy. Airy ने कहा no, you all are wrong. Sial का average density is same. Earth is made up of rocks of the same density, and therefore ऐसे नहीं कह सकते कि हिमालयास का रॉक are of less density. Understand this small concept. Concept is very easy. Or this rock is of made up of different density, and he for that did an experiment. Right? What he did in an experiment, he took wooden blocks, or he took blocks of the same mineral, because Earth's crust, Earth ka rocks are more or less same, and subjected them in water. Fine. So this is the level of water. And after taking the wooden blocks and after subjecting them in the water, he realized that the wooden blocks were of different shapes. One was of this shape, one was of this shape, one was smaller than this, of this shape. And he subjected them in water, and he found somewhat like this happened. जो बड़ा block था, it went deep inside the water. जो कम block था, it went less deep inside the water. जो और कम block था, it went for less deep inside the water. To make the diagram good, we draw the diagram like this. Means what is this? Higher the mountain, deeper is the root. Lower the land, lesser is the root. This is what he did with the wooden blocks. इसी को आपको change करना है in geographical terms. Means the diagram will come same like this, but the diagram will be slightly different. This diagram should come in the paper for value addition. I am asking you this diagram: mountain, plateau, plain, plateau and plain. Fine. Plain, less root. Plateau, more root. Mountain, deeper root. Getting it? The only difference is this is Sial and this is Sea. That is, deeper the mountain, higher the mountain, deeper is the root. That is they are floating. Fine. And if you look at the first, show me the first Sial Simaka diagram in our notes. We have drawn the same thing. Getting it? Why this diagram? Why not the straight line? Isostasy. Why our first deep? Higher the mountain, higher any landform, deeper is the root. So everyone said, wow, this is very right. इसीलिए when you measure the gravity from the surface, ये जो root अंदर है, it is not exerting any gravity, and therefore deflection नहीं होता towards the surface. But then आया Pratt ने कहा ये सब बकवास है, ये सब wrong है. Why? Because if you go 80 kilometers deep inside the earth, after 30 kilometers, that is the depth of the crust, and from 100 kilometers deep inside the earth, 80 to 100 kilometers, still 200 kilometers deep inside the earth, what is there? Asthenosphere. So if he is saying that Himalaya, Mount Everest ka height is 80 kilometers deep, it is not possible, because after 30 kilometers there is a presence of magma till the 200 kilometers, and such an at high heat everything will melt, and therefore एरी इज रॉन्ग. गेटिंग इट? सो प्रैट ने क्या कहा? प्रैट ने लिया सेम, एक बर्तन लिया, उसमें डाला mercury instead of water. So this is now mercury. Then he took iron heavy. उसके बाद he took lead and he took one more lighter material. I'll take wood. Fine. Iron is densest. उसके बाद sorry not lead. He took, I'll take tin or aluminium and wood. This is for your understanding. And he put them in the mercury. जो iron का block था, it went deep more. जो aluminium था, it did not went that deep. It was floating. जो wood का था, it was still floating. So wood is mountain. This is plateau. This is plain. So that is mountain, lighter rocks, not the same rocks. Fine. Aluminium, plateau, and iron is the plain. This is what is the isostasy. बस यही लिखना है. Concept is very easy. Fine. You have to compare Airy and Pratt. Airy कहता है there are different roots. Fine. And Pratt कहता है नहीं, there are no different roots. There are different densities, but the root is same. Root is same, and this is what Pratt says as the level of compensation. Who is more right? Pratt is more right. Why? Because yes, if you go very deep, then the root will melt and the entire mountain will melt. Getting it? Khatam theory. Very easy concept. The only thing is start. इसको समझना is difficult. Fine. We'll continue tomorrow then.